Okay, thank you, Katherine. That was awesome. Next up, we have Casey Wilson, another 2019 Knauss Fellow working as an Electronic Technologies Coordinator in the NOAA Fisheries Office of Science and Technology. Casey recently completed her doctorate degree at Scripps Institution of Oceanography, where she studied applied ocean science and used passive acoustics to study the ecology of grouper in the Cayman Islands. Prior to this, she received her BS from the University of Portland and an MS from Clemson University, both in electrical engineering, and worked as a communications engineer for Bonneville Power Administration for 3 years. In addition to her diverse background in bioacoustics, intelligent systems, and network security, she comes from a commercial fishing family and has worked as a deckhand fishing for Chinook salmon and albacore tuna on the fishing vessel Joel. Today she will be presenting one of her chapters from her doctoral work, Applications of Passive Acoustics in Fisheries, Observations of Grouper Spawning Aggregations and Source Level Measurements in Little Cayman, Cayman Island. All right, thank you.
Hello, everyone. As Katherine said, thank you for joining us today for our talks. For the last 5 years, I've been listening to grouper sounds, and grouper sounds of 4 species. And in addition to these 4 species, there's over 800 other species of fish that actually produce sound. And fish produce sound in 2 broad contexts. First, courtship-associated sound, so related to spawning or trying to attract mates, and also in agonistic encounters, so aggression or upon disturbance. And we can use these sounds as a way to actually monitor these species. So how we would actually go about doing this is to then use passive acoustic monitoring, and we would deploy hydrophone recorders, as you can see here on your right, out to collect these sounds. And by doing this, then we can know when animals are present, and we can study the temporal and spatial trends of these fishes. And then we can also use passive acoustic localization to track the position of these sounds, start to understand movements of fishes, habitat use, and work towards abundance estimates by making measurements of source levels, which is essentially how loud a sound is, how much energy is contained in that sound, and work towards understanding the call rates for these species and other information that's needed to develop these abundance estimate methods for passive acoustics. Now, passive acoustics has advantages over other methods for fishery data, and this includes over trawl surveys, visual surveys, and as well as acoustic telemetry, because it's non-invasive. You can gather continuous long-term data for months to years, and you're not limited by weather, light, and other conditions that some of these other methods are. So I've been using passive acoustics to study 4 species of grouper, Nassau grouper, red hind, black grouper, and yellowfin grouper. And these fishes range through the Caribbean, Western Atlantic, and Gulf of Mexico. They contribute significantly to the commercial and artisanal landings in many of the countries in this region. And due to this, due to high fishing pressure, a lot of these species are now near threatened to endangered. Nassau grouper is an endangered species, and these other 3 species, either at least in some areas or throughout their range, are near threatened. And this high fishing pressure is usually on spawning aggregations, and this is where many fish, hundreds to thousands of fish, gather at predictable times and locations. So once a spawning aggregation is found, it becomes vulnerable to this fishing pressure. So I'm able to use passive acoustics to study these 4 grouper, because as I said, they produce sound and their sounds are known. So I've actually looked at 9 different call types. And what I'm going to be talking about today, though, is a smaller subset. It's the courtship-associated sounds. So I want to orient you to what you're looking at here. This is a Nassau grouper courtship-associated sound. And we're going to see through this presentation today a couple things, the labeling, and 2, I'm using a letter to signify what species I'm talking about, and in the case for fish that produce more than 1 call type, you'll also see a number. You can notice on the bottom this is blue, so I have color coding for the different call types as well, which you'll see. And what we're looking at here is 2 ways to actually visualize sound. We have on the bottom our pressure amplitude, and on the top is a spectrogram, and this is just showing energy over time on our x-axis and over frequency on our y-axis. So when the energy is high, we're seeing the red versus low energy ambient background noise in the blue. So I'm gonna have to come back and forth. I'm gonna play a couple of these sounds for you. Maybe. And then for red hind, all of the yellowfin calls, which are actually going to be combined, because this was the lowest occurrence of calls that we had were for yellowfin. So when presenting the results, these 2 calls that were combined together, and black grouper. Now, all of these sounds are low frequency, which is, for example, if you're not familiar with frequency, men generally have lower frequency voices, women higher. So that's what I'm referring to when I say frequency. It's really the pitch of the sound. And these are all low frequency, fall into the same band as ship and boat noise. Males are the ones that are known to produce sound in these species. And as you can see, looking at these spectrograms and the pressure amplitudes of these calls, each of these species has stereotypical calls that are unique to that species. So using these sounds, my objectives are to look at spawning aggregation dynamics. Where is calling, or when does calling occur, where does it occur, and then look at how this actually relates to what we know about the spawning behavior of these fish, and additionally to measure our source levels to understand how far our hydrophones could actually detect these sounds, and eventually work towards understanding the communication ranges of these fish and developing abundance estimates. And my hope is that going through this presentation, you'll start to understand why passive acoustics is a valuable tool for fisheries. So we've been collecting data at a Nassau grouper spawning aggregation in Little Cayman, the smallest of the Cayman Islands. And this Nassau grouper spawning aggregation usually occurs in January or February following the full moon. And it occurs at the west end of Little Cayman. It's the largest known remaining spawning aggregation of Nassau grouper. And in addition to Nassau grouper, I should say all 3 other species have either been observed spawning or displaying spawning behaviors in this area as well, and share a similar spawning season over those winter months. So to collect our data, we've deployed passive acoustic recorders out in this area. We actually took video footage of the habitat, and that's what you're looking at here on our right. You can see the darker green is the coral relief, the lighter green is our sandy spots in between, and from that we reconstructed a bathymetry map, And you can see here that all these 6 hydrophones that we put out range from 25 to 35 meter depth. And I manually went through all of this data. It's extensive. We're talking about thousands of calls, upwards of thousands of calls. And I logged all the calls that were recorded on recorder 5, the most northern recorder here. And from those calls, then to work on doing localization, I have to have at least 3 usable call arrivals. So to give you an example, I'm showing you here a red hind call and the arrivals on all of these receivers here, or hydrophones. And on the top, I'm showing you hydrophone 5 because this is where I actually logged calls. So I use the arrival on hydrophone 5 as a match filter to then help me determine if there's usable call arrivals on our other channels. Looking at this example, I think it's fairly clear that not all of these calls arrive at a higher level than our background noise. And so what I've used is a number of different thresholds, including that match filter output, to automatically determine if I have enough usable arrivals to do localization. So if I do, which I said for 2-dimensional localization, this actually has to be 3 or more arrivals, call arrivals. So if I have that, I can then move ahead, and to do hyperbolic localization, we take pairs of arrivals, we cross-correlate them, so that's essentially taking one of those arrivals and then just moving the other call over it. Where they best align is where you're going to get a peak in the output of your cross-correlation. And then at that peak, it gives you what the time difference of arrival is between those 2 calls. From there, you can solve an equation that will restrain the position to somewhere, the position of the fish producing this call, somewhere along this hyperbola. And why we need 3 is because then we can put multiple of these hyperbolas together, restrain or resolve our ambiguities, and ultimately when working with more than 3, we can use it as a least error solution to find an estimate of this position for where the call was produced. And this estimate, as you can see in this example, they don't all align, so there's going to be a residual error associated with that. Now, to get our source level measurements, there's a couple ways to do this. What I'm going to show you today are actually peak-to-peak source levels, and we just measure this from our pressure amplitude. We get our receive level, the peak-to-peak receive level, at our hydrophone, and we've solved for our position, so we know the distance it is from the hydrophone. We can then determine what our transmission loss is and work backwards to get the source level at 1 meter from the source. For my work, I've used 200 of my localized calls for each of these call types. It was the calls with the lowest residual error, and I assumed spherical transmission loss. And just for people who aren't familiar with underwater sound, usually report this in dBs or decibels, and this is referenced to 1 micropascal at 1 meter. And an example to give you a feel for how loud these source levels might be when we get there is we have sonar ranging above 200 dB, ships from about 170 to 190 dB, and our baleen whales all the way up to almost 190 dB as well. So to move into the results, what we're looking at here then is the call number of calls per hour over our full deployment duration. And I'm showing you all the call types that I worked with. This includes those agnostic calls, but what I really want to focus in on is our Nassau grouper calls, this N2, where we have a lot, and our red hind calls. So on these plots, where we have no data is in gray, the slider gray is indicating nighttime, And we have here a lighter blue, which are actually the nights that Nassau grouper spawned. And we can see that generally, both Nassau grouper courtship-associated sound and red hind sound have increased. Those calls increase following the full moon, for Nassau grouper peaking 5 days after the full moon, and for red hind then peaking right at that first quarter moon. Additionally, if we look at Nassau grouper spawning nights, we can really see that peak calling occurs right after sunset. And if we look at the 2 days of peak calling with red hind, we're seeing that calls are peaking right at sunset. So if we move into localizations, I'm going to pull out and show you all the localizations I was able to do for 2 days of peak calling for both Nassau grouper and then red hind. So this video, I'm going to play in a second, going to see some similar things to what we just saw on those temporal plots. It's going to be, the background is going to be changing colors, dark gray being nighttime, light gray being those twilight hours, sunset, sunrise, and then it'll be white when we're in the daytime. Additionally, at any instant, what you're actually going to be looking at is an hour of localization. So an hour of calls, all the calls that I was able to localize. The calls that are happening at the time indicated up here are going to be our darkest, and as the hour moves on, they'll begin to fade away. And I'm going to be scrolling through 1 minute at a time. It's sped up, and I'm going to try to talk through some of what we're seeing here in these localizations. So we can see, sorry, that we have Nassau grouper calling activity shifting around in the array. So at different locations, we're seeing peak calling. When we get to right around this time where it's sunset, we see calling pretty much stop in the area, and then it increases substantially afterwards. So run that through again, and what we're seeing at that sunset hour is actually Nassau grouper moving out of our array. They go off the shelf edge to spawn, and then they come back after spawning and settle back down on the shelf in the array, and that's where we see this huge abundance of calls. So we're going to start to see it right in this time, calling stop, all of the fish returning. So we have then, as just a summary, as to show you similar to these localizations, now I'm just changing our color bar here. We're seeing a whole hour of our calls. We see from around about 17:30, when sunset actually occurs, calling stops, and it doesn't really start again until around 18:30, and we see a highest number of calls at the 2000 hour. So again, we're going to look at the same thing for red hind. We're on a different day though, same types of plots or videos. And what's interesting with these ones is you begin to see sometimes we're calling stops in the array. One time is at sunrise, and we can start to see, and this is more apparent in the later hours, some specific areas where there's going to be high activities of calls. Now, red hind spawning behavior is very different than Nassau grouper. Males form territories, and then they patrol these territories. They're not known to actually leave their territories during their spawning aggregations. And so looking at that, what I'm able to conclude about these localizations is that calling actually, probably red hind likely stops calling at sunrise. You can see this here in these plots, calling after about 6 a.m., it stops, and we don't see calling pick up again until closer to 9 o'clock. And because they're not known to leave their territories, this would mean that they actually stop calling, unlike Nassau grouper, who left the area, and that's why we're probably seeing no calls during that spawning time. We also then can see that the red hind calling really peaks at at sunset, when Nassau grouper were not normally present in the area. And this is an example of really trying to highlight those 3 areas that, when I look at the abundance of calls over this whole area, really stood out as having higher activity and might be red hind territories. So then final results is then our grouper source levels, and showing you here histograms of the number of calls on our y-axis, and then what those source level measurements, peak-to-peak measurements, were for these calls. On a couple of these call types, because if you can remember back to the spectrograms, there was different sound components that these calls are composed of. For a couple of them, I broke them out and actually measured those distinct sound components. But overall, what we're seeing is that their source levels range on the low end for yellowfin at 144 dB to the high end of 155 dB for Nassau grouper. And what this really means is that then the detection range, so how far we could detect these sounds with a hydrophone recorder for your typical shallow water ambient noise conditions, would be 0.3 to 1 kilometer. And remember back, our baleen whales were up to 190 dB. One thing to know about dBs is every 3 dB difference is actually a 50% reduction in power. So if it's 3 dB lower, it's 50% less power. So compared to 155 dB to 190 dB, fish are much quieter than whales, than ships, than many other things out there. So to summarize, looking at spawning aggregation dynamics, we're seeing that during spawning for Nassau grouper, we're getting peak calling right after sunset. We're seeing peak calling for red hind actually at sunset. And what we're seeing in our localizations, then we're actually able to see a change in the calling in our array due to the spawning of Nassau grouper and the movement of the aggregation. And we are possibly seeing red hind territories as well in those localizations. Additionally, with those localizations, we might be able to pull out individuals, where you could see that a lot of activity when watching those movies in a specific area might be a single individual, and then you can work towards making estimates of some of the things, other factors we need to develop abundance estimate methods. With our source levels, we saw the detection ranges 0.3 to 1 kilometer. Now we can move towards measuring hearing sensitivities of these fishes, and would actually be able to then determine what the communication ranges are for these animals. And as I said, the source levels is one step in moving towards those developing robust abundance estimates using passive acoustics. So my work was done as a collaborative effort with many people. So I'd like to first thank my advisor, Anna Sarovich, and then my collaborators on this work, Bryce Simmons, Jules Jaffe, Grouper Moon Project that's been studying this population of Nassau grouper since the early 2000s. It involves many people, including Steve Giddings here, and the Cayman Island Department of Environment has been involved with all of that work as well. And take any questions.
Is this area protected at all from fishing pressures?
Yes.
Okay.
Yeah. So they've had Steve might be able to answer this better than me right now, as I'm saying, but protection since I believe 2002 regulations, and they've been seeing what appears to be a recovery in the population of Nassau grouper since that time. It's just a no catch during all the way through March of any Nassau grouper.
So it's closed during the spawning?
Yeah. I think
Okay.
from December to March.
Interesting.
And then there's limits on the catch outside of the spawning season,
Yeah, okay.
as well as on the gear used for fishing.
So you can fish Nassau grouper in the Cayman Islands?
Yes,
Okay.
just outside of that spawning
Okay.
season, and then limited gear for how you can catch them, and limited number of catch as well.
All right, thanks.
Yes.
Okay. Great talk, by the way. I was just wondering if you had any issues with boat noise interference, and if so, how you dealt with that.
So yes, I also have issues with other noise, strumming, or flow noise from on the hydrophones, and how I dealt with that is actually to just remove that data. I didn't look at it, and then to get my hourly calls rates normalized based on the amount of time of data there was that didn't have noise,
Okay.
and adjusted it that way.
Cool, thanks.
So it's neat how you've been able to isolate the end of spawning, because all the diving we do, we never want to go in later because everybody wants to see the spawning. So we never see the end of it. But you've been able to now find out when the fish finish.
Yes. Yes.
That's good.
And another big thing that I didn't mention through the talk was to really look at what might be happening at night if there was more activity, but the calling really drops off after it looks like Nassau grouper returned to the shelf, and likely there isn't then any more spawning activity. In the back?
Hey, really cool stuff. Has there been any work looking at the relationships among size of males and sound production to try and get any kind of size frequency information in addition to abundance estimates?
Not.
Could you repeat the question?
Oh, sorry. The question was whether or not anyone's looked at any relationships between size of fish and the source levels of their calls. And for these species, no, actually these were the first source level measurements for Epinephelus, the family Epinephelus. For some other families and species, I believe people have done that, but not in the wild. And generally, there is a correlation when looking at these other species or other animals, a correlation between size and source levels. But when I look at the various source levels of these grouper, red hind is much smaller, and their source levels seem to be in the same range as the other. So between species, that same relationship doesn't appear to hold, but within species, it may. Yes.
That was a great talk, really interesting. I was wondering if you have any thoughts as to why the courtship-associated vocalizations would increase when they come back from the spawning grounds, or from the spawning aggregation.
The question was, why might the courtship-associated sounds increase when Nassau grouper return from spawning? And I guess my thoughts on that are two things: whether there's hormones driving it, so the hormones might still be high after spawning, but as well as we're talking about thousands of fish that gather in this area. So they're coming back and settling down, and may just be, they do have their agnostic, more aggressive call types, but they might still be producing this courtship-associated sound in another context as they all try to settle in for the night.
Okay, and so we could do an online question. Someone who's working with the black sea bass asked, they said, we're very interested in a means of assessing abundance in untrawlable areas. Any advice for using passive acoustics?
Yes. So looking at marine mammal literature is really where you have a lot of guidance on how to do abundance estimates using passive acoustics. So first step would be determining what the source levels are, as I've done here. And then you also need to know other things such as, is it only males producing sound, or do both males and females? Have some idea then about what those population ratios may be. And you can work towards, with using localization, like I've done here, possibly trying to understand cue rates, so how often is a single fish calling, and with all of that information, including the probability of detection on your hydrophones, that's how then you can work towards developing those abundance estimates. So to understand how many fish might actually be in the area that you're able to detect calls over with your hydrophone. I hope that helps and answers it.
Great, and then we can just make this last question. We're running over a little bit, but this person wanted to know, how did the source level compare to the loudest call recorded for red hind and or Nassau?
So, let me scroll back actually. So, because I had listed the full range of the source levels. So, I can't see it on with that thing, sorry. Okay, thank you. Our loudest red hind call, 163 dB. Our loudest or highest source level Nassau grouper call is 168 dB. So that's lower, but in the same range. And
great. All right. Well, thank you, Katherine.
Thank you. Thank you very much for hosting this, and Hollis for putting it all together for us today.